Hello and very good evening to all of you. Welcome to Resultant AJ YouTube channel. I welcome you all to this very important session on the subject of fluid mechanics for RRB JE 2024. So my dear students, as you all know that, just a second. As you all know that for RRB JE 2024, we have started this particularly this new YouTube channel for Resultant AJ, and after the announcement of notification, as you know that after 5 years we are getting we have got RBJ notification, so it's very special. And so you guys, those who are following basically those who have applied for RBJ and you're preparing through our YouTube channel, whether it is non-tech classes or technical classes, do let us know how you are enjoying these classes, how you are getting benefited from these classes. Okay, so very good evening everyone, welcome to this session. Just let me know if my audio and video is fine or not. Yes, and those who have already joined me for this session, please do not forget to like the session, share the session, and subscribe this YouTube channel which you have recently joined. Okay, and just at the on the side of the subscribe button, you can see this bell icon. You can just hit the bell icon and all the notification from this YouTube channel will automatically it will be notified, like you get a notification in WhatsApp or Telegram or any other app. Okay, my dear students, as you know that we have started this game changer series, and in this game changer series this week I'm basically taking the previous year questions. In the yesterday class I have taken the previous year question on subject of thermodynamics, which is only important for mechanical, but as you know that fluid mechanics subject is important for civil and mechanical branch. यानी कि civil mechanical के दोनों ही students आपके benefit हो सकते हैं, they can get benefited from these classes. So please let me know if my audio and video is fine. Hi Prisma, good evening, कैसे हो आप? So this is the basically fluid mechanics subject that we are going to solve some previous year questions on fluid mechanics. And if you are meeting me for the very first time and you have no idea who I am, then my name is Vikas Sir, and I have over 7 years of experience teaching for different competitive exams, whether it is GATE or engineering services or any other JEE level exams or any PSU exams. Okay, so I have been doing this from the last 7+ years. I have experience and I have taught many subjects like fluid mechanics, thermodynamics, applied thermodynamics subject. And if you talk about my qualification, after my BTech I have also done my masters, and I have qualified GATE many times, cracked GATE many times, and these many students I have mentored. Well, a very important announcement for all the students. As you know that Independence Day sale, Independence Day is this is basically the week of Independence Week, and as you all know that, yes. Yes, Atin Saini, how are you? कैसे हैं आप? Enlightenment Academy. Yes, yes. Grade up वाले sir. And grade up वाला लोगों भी. Yes. GATE Engineering Services RRB JE. So these are the exams जिनके courses हमारे पास हैं, and if you are preparing for this examination, you want to enroll with the courses of RRB JE or any other exams, then you can get 55% discount on our courses if you use India 55. This is a coupon code you can use अगर आप ज्वाइन करते हैं हमारे कोर्सेज को, एंड ये वैलिड है, दिस इज वैलिड ओनली फ्रॉम 14 to 16 अगस्त. ओके, तो टुमारो ऑनवर्ड्स इट विल बी स्टार्टेड. ओके, कल से स्टार्ट हो जाएगी ये जो सेल है. ठीक है, हमारे कोर्स पे डिस्काउंट आप अवेल कर सकते हैं 16 अगस्त तक. अगर कोई क्वेरी है तो आप इस नंबर पे कॉल कर सकते हैं या यहाँ पर मेल भी कर सकते हैं. और मैं बता देना चाहता हूँ, आई वांट टू टेल यू दैट दीज आर द फैकल्टीज फॉर द सब्जेक्ट ऑफ मैकेनिकल. धीरज सरदाना सर, विकास भदौरिया, दैट इज मी, चंद्रशेखर सर एंड सूरज गोपी सर. ऐसे ही लिख लिया. That's very good, Atin, and I also know that you also teach. You are also a faculty in a coaching, and so that's very great. अच्छा काम कर रहे हैं आप. So आप देख सकते हैं यहाँ पर RRB JE CBT 1 के लिए we have a focus batch, MRP प्राइस इज 4999 बट अभी डिस्काउंटेड प्राइस है आपका 2499। अगर आप अवेल करते हैं इसको 16 अगस्त तक, then this will be the offer price, and these are the courses CBT2, RRB JE, and combined CBT and CBT2. Okay, they are different batches, and AIM batch जो है हमारा, it is for CBT2, RRB JE, CBT2, and it is a batch which is basically in English. We will be teaching you in English language only. Method of teaching will be English, but mode of teaching will be English, and total 400 hours of course will be there. AIM batch. Second is mission batch, which is a batch for CBT1 and CBT2 both, combined batch for RRB JE, and the price is 5499 right now. Let's come to the questions. First question on your screen, my dear students. आपके स्क्रीन पर पहला क्वेश्चन आपके सामने है. The reason I am repeating the things in Hindi, so that all the students, whether you are from north or south, anywhere, you can get benefited from these sessions. Although English is the preferred mode of teaching on this YouTube channel, but जो भी students English नहीं समझ पा रहे हैं, अगर कुछ explain करना है, if I have to explain something, I will explain in Hindi also. An ideal flow of any fluid must satisfy. Ideal flow of any fluid must satisfy Pascal law, Newton's law of viscosity, boundary layer theory, or continuity equation. Now, continuity equation, as you guys know, that it is based on conservation of mass. Conservation of mass, it is based on conservation of mass, right? Which says that total mass flow rate at the inlet of any control volume is equal to total mass flow rate at the exit of a control volume. Why I am saying control volume? Because this is only applicable in an open system, right? Remember? And if you talk about subject of fluid mechanics, so fluid mechanics subject also, when we say fluid is flowing, that means continuity equation has to be satisfied. An ideal fluid flow must satisfy the continuity equation. You know different forms, that is A1 V1 is equal to A2 V2. This is also continuity equation. This is a continuity equation for incompressible fluid. Okay, incompressible fluids. It is my request, please share the session also. I have been, as I mentioned yesterday also, earlier I told you that I will not be teaching, but I am teaching here. And so please, I request everyone to follow these sessions. I know that you have got many options free. In free, you have got so many options. When you have taken a course, तो आप कहीं से भी पढ़ सकते हैं. When in free, you have so many YouTube channel options. So, but if you particularly love how I explain the concept, मैं कैसे पढ़ाता हूँ, तो आपको अगर अच्छा लगता है, और हमारे जो फैकल्टीज़ हैं, जो भी फैकल्टीज़ हैं आपको जानते ही हैं, सूरज गोपी सर, धीरज सर, तो आप हमारे से पढ़ सकते हैं. ऑन यू कैन स्टडी फ्रॉम आवर यूट्यूब चैनल. Which of the following represent steady uniform flow? Steady uniform flow. Steady means no change with time. No change with time. Time के साथ कोई change नहीं होगा. No change with time. And uniform means, what is the meaning of uniform? Uniform का मतलब होता है, uniform flow means a flow which does not depend vary with position or location. तो position या location के साथ vary ना करे, that is your uniform flow, right? So which of the following will be the example of steady uniform flow? Flow through a diverging duct at an increasing rate. What is the meaning of rate? When we say increasing rate, that means we are talking about unsteady. This is unsteady. Okay, increasing rate. Decreasing rate or increasing rate, we are talking about unsteady. Rate means, generally when we say rate, we are talking about change with time, with respect to time. This is also decreasing rate. That is, when we say rate of, that is, we are talking with respect to time, then we say that this is also unsteady. So all these option A, B and D are the case of unsteady. Only option we can say constant rate. Rate means with respect to time it is constant. What is constant? Flow is constant. Flow is constant, right, at a constant rate. That is, this is steady. And why it is uniform? Because when the flow is taking place through a long pipe, let's say we have a long pipe which is having a long pipe, so the flow parameters not only become steady with respect to time, but also Also it becomes uniform flow. Okay. Next question, consider the following statement regarding a path line in a fluid flow. So there are three definitions with respect to path line. I request everyone, please follow these sessions. Yes, everyone. Just a second. I think there's some issue. Am I audible to all of you? So 3 students who are taking the classes, that's very great. See, आप में से काफ़ी लोग ये इतना तो समझदार हैं कि that it's not that RRB JE CBT2 will be in the month of maybe October or November, whenever it will take place after CBT1. So you must be thinking, sir, why to study for CBT2, right? Because technical subjects are only important for CBT2. But let me tell you that SSC JE CBT2, those who are preparing for SSC JE also CBT2, that then this session is also helpful for those students. So please do not take this session like when the exam will come, then we'll study. Okay, I tell you this every day. This is what I used to tell you. Please follow the sessions. All right. Okay. A path line is a line traced by a single particle over a time interval. A path line shows the position of same particle at successive time instant. A path line shows the instantaneous position of a number of particles passing through a common point at some previous time. This is not a path line. This is not correct. Okay, path line is a line traced by a single particle over a time. Let's say we have a single particle. This is a particle. Now at different time instant, this is time is equal to 0 second, let's say. After some time, this particle will reach this point. Let's say after time is equal to 2 seconds. After some point, some time it will reach this position. Let's say 4 seconds. Okay. So this is the movement of this particle. This particle is moving from A to B to C at different time interval. You can see this. This is called a path line. And it also shows the position of the same particle. Same particle is moving now. So it shows the position of same particle at successive time instant. So both 1 and 2 are the definition of path line. What about option number 3? What about the third statement? The third statement is not a path line. Instantaneous position of a number of particles passing through a common point. So this is basically a streak line. It is a streak line. It is not a path line. Okay. Next, what is the discharge for laminar flow through pipe of cross-sectional area 0.05 meter square having velocity of 2 meter per second? आपको discharge find करना, you have to find the discharge. Now you know that discharge is also called as volume flow rate या volumetric flow rate या volume flow rate is also called discharge, and that is equal to area into velocity. A is basically area is given 0.05 and velocity is 2. This will come out to be 0.1 meter cube per second. Okay, so this will be the discharge. Hi Pushpen, good evening, welcome to a session. The water is inserted at 10 meter per second velocity through the nozzle of water on the 0.015 meter square area. It impinging perpendicular on a plate which moves away from 5 meter velocity. So basically what is happening here, that we have a nozzle, and from that nozzle the jet is coming, and jet is falling on a plate, and that plate is lying perpendicular. Okay, the plate is lying perpendicular. And also, my dear, the velocity of the jet is equal to 10 meter per second. And this particular plate can also move. This particular plate can also move at what velocity? It can move at 5 meter per second. So what will be the force applied by the jet on this plate? The force which will be applied, that is normal force is equal to density into area into relative velocity square. Relative velocity is velocity of the jet minus velocity of the blade. So you just put the values. So density of the water is 1000, area is 0.0015, velocity is 10 minus 5 square. Just put all the values and you will get the answer. Tell me what is the answer you are getting. Yes, everyone. If you find this calculation tough, you can also use your calculator, because in your exam of RRB JE CBT2 and SSC JE CBT2, calculator is allowed. Okay. So since calculator is allowed, so you will get 37.5 Newton. So why do they do mistake? Why to do mistake and why to waste your time? If let's say if in RRB JE CBT2 you are giving CBT2 of RRB JE or SSC JE, where calculator is allowed and you have to do a small calculation, but that calculation if you think that I will do without let's say without calculator, but you are taking more time without calculator, so it's not wise decision. Okay, अगर calculator आपको allowed होता है in CBT2 of RRB JE and SSC JE, then use calculator, save your time. A streamlined and equipotential line in a two-dimensional in viscid flow field are identical, are parallel to each other. I am not able to understand one thing, that what has just happened in just 1 week. एक हफ्ते में ऐसा क्या हो गया है कि आप लोग क्लासेस को फॉलो नहीं कर रहे हैं, not following the classes. It's my request that please do come in the classes, please attend the classes. It's important. Or you think that YouTube classes are not that basically engaging, you can also let us know आप क्या करना चाहते हैं, आप किस तरह से आप चाहते हैं, what kind of session you want, what you want to study, you can also let us know. We can plan our classes accordingly. Okay, आप हमें feedback भी दे सकते हैं that sir we want this kind of classes and sir we want this particular thing, and if you can just provide us, we can definitely attend more number. So number is not important. Important thing is, if in this YouTube channel we have 570 students who have joined the YouTube channel, and let's say out of this 70 students are from mechanical, let's say 70 are from mechanical, so at least out of 70 students, at least 10 to 15 should come daily, at least minimum. The answer is option C, perpendicular to each other. You know that streamline and equipotential line, right? If you see the slope of streamline, slope of the streamline is equal to what? It is dy by dx. If you find it, and if you find the slope of equipotential line, equipotential means velocity potential line, right? Equipotential line, dy by dx. If you solve this, you will get that if you multiply these two, you will get this is equal to 1 or minus 1. That means they are perpendicular to each other. Okay, clear? If you want to find the slope of equipotential line, let's say, what is equipotential function? Velocity potential function is phi, which is a function of x, y and z. It varies in all the three directions. So u component of the with respect to velocity potential function is minus del phi by del x, and v component is velocity is minus del phi by del y, right? Is it clear to everyone? So if you want to find with respect to what is dy by dx, so what will be dy by dx? Tell me. So u is equal to, u into dx is equal to minus d phi, and v into dy is equal to minus d phi. If you equate these two, what you will get? That dy by dx will be equal to, dy by dx will be equal to what? U by v. And likewise you can find the slope of streamline. Slope of streamline you will get, that is dx by u is equal to dy by v. From here you can get the slope of, so if you solve it, you will get this is, they are perpendicular to each other. To ensure the stability of a floating ship, which of the following condition must be satisfied? To ensure the stability of a floating ship, which of the following condition must be satisfied? Floating ship means partially submerged ship. What is the meaning of floating? Floating means partially submerged. Okay. Partially submerged body, like ship is a partially submerged body. Which of the following conditions should be satisfied? So when we see a floating body, what we see? Floating body stability condition determined by meta center. Then we'll see the position of meta center. Okay, when we see floating body, then we see position of meta center, and this meta center should be above the center of gravity. Center of gravity should be below meta center. So option B will be the right answer. Very good. Okay, what is the stability condition? The meta center should be above center of gravity, or center of gravity should be below meta center. So this is a stability condition for a floating body. Okay, floating body. Clear? Or this is a condition. Center of gravity should be below center of buoyancy. This is a stability condition for fully submerged body, right? Remember, कल को पूछ सकते हैं आपसे. This is a stability condition for fully submerged body. Clear? Next question, find the buoyant force acting on an aluminum cube which is suspended and immersed in a jar filled with water when it is given that side of the cube is 5 centimeter. So we have in this question it is saying that we have aluminum cube and you have to find the buoyant force acting on the aluminum cube. Try to solve this question, right? It's a very simple question. Just try to solve it. So we have 3 students. Thank you so much for coming in the classes. That's very sweet of you. Pushpin, the Prisma, and with the third one. I think there's 3 students in the class. Okay, solved, done. So you must have studied that whenever a body is a floating body or fully submerged body, right, then the buoyant force is equal to weight of fluid displaced. You have studied this? You must have studied this. Displaced. Just a second. Displaced. So what is weight of fluid displaced? This is equal to density into G into volume. Okay. Now in this particular case, the buoyant force is equal to density is equal to, obviously it is water, so it will be 1000. G will be 9.81, and what will be the volume? Volume is cube. So since it is given a cube, so you have to put the volume of the cube. Okay, so you can just put the value. So it is 5 centimeter, 5 into 10 ki power minus 2 meter square, sorry, cube. So if you solve it, you will get 1.25 Newton. Okay, this will be the answer. Please try to solve it, you will get the answer. Next, when a ship travels in a sea, which of the effect is more dangerous? When a ship travels in a sea, which of the following effect is more dangerous? I hope that you guys have studied this concept. Just a second. Have you studied this concept? When you design the stability condition of a ship, like you know that there are 2 types of motion of a ship. right? One is called pitching, one is called rolling. So when we say stability condition, yeah. So the right answer for this question is option number C, that is rolling. So you must have studied that ship is a partially submerged body. Ship is partially submerged body. Okay. And since ship is a partially submerged body, then you guys know that for a partially submerged body, what we see? We see metacentric height. Metacentric height हम देखेंगे. We'll see what is metacentric height, which is given by gm, and gm is equal to what? What is the formula? I by v minus bg. You must have studied this formula. Remember the formula or not? This is how you find the metacentric height, and this metacentric height should be positive. Remember? So if we say that, so more is the metacentric height. More is metacentric height. More will be stability, right? Now if you see a position of a ship, अगर आप ship को देखते हैं, so there are two types of motion of a ship. One is this kind of motion, one is about this. So this is one axis, this is one axis, and this is second axis, axis number 2. These are two types of motion about which these are the two positions about the ship can have motion, right? Can you tell me that if the ship is moving about axis number 1, it is moving, then this motion will be called as what? And if this is moving about this axis, it is having movement about this axis, axis number 2, then this motion is called what? Can you let me know? Tell me, everyone. Can you define what is the motion of the ship about axis number 1? Yes, tell me. See, you guys don't have to just answer my question ABCD. You need to also understand this concept. What is the meaning of rolling and pitching? Okay, क्या होता है rolling pitching? So if the ship is moving about this position, axis number 1, it is called rolling, and if it is having motion about this axis, that is called yaw axis, this is called pitching. Okay. So as you know that stability of a floating body depends on metacentric height. More is the metacentric height, more will be the stability. And if you see this particular formula, this is called moment of inertia. The moment of inertia of a ship about the pitching axis, about the rolling axis is less than the moment of inertia about the pitching axis, right? If you find the moment of inertia, you will see that. Also this whole value that is I by V, this is also less for the rolling and as compared to pitching. आप लोगों ने कंसेप्ट पढ़ा होगा फैक्टर ऑफ सेफ्टी का. फैक्टर ऑफ सेफ्टी का ये कंसेप्ट होता है, द कंसेप्ट ऑफ फैक्टर सेफ्टी सेज दैट व्हेन वी हैव टू डिजाइन अ पर्टिकुलर सिस्टम, वी डिजाइन विद रिस्पेक्ट टू दैट सिस्टम विच इज वीक, राइट? सो सिंस दिस पर्टिकुलर थिंग, जिसका ये वैल्यू ज्यादा होगी, जिसका दिस राइट, दिस वैल्यू विल बी मोर, सो दिस वैल्यू विल बी मोर. दिस इज सिंपल मैथमेटिक्स. If I by V, this is called moment of inertia divided by volume of displaced fluid, right? If this will be more, then this will be more, right? So it is very clear that I by V for the rolling axis will be less as compared to pitching axis. That means the ship will be weak in the rolling, right? So that is why the ship will be when the ship travels in a sea, the effect about the rolling axis is more dangerous, right? The ship should be designed based on the rolling condition. Are you getting my point? मेरी बात समझ में आ रही सभी को? So that is why ship should be designed about the rolling pitch. Sorry, rolling axis. Next, for a submerged curved surface, the component of force due to static liquid is equal to. For a submerged curved surface, the component of force due to static liquid. So we have a submerged body. Submerged means it is fully surrounded by static fluid, like let's say water. We have a curved surface, right? So we have a curved body. Let's say this is a curved body, and this curved body is fully surrounded by water, which is a static fluid, a static liquid, right? It is at rest, and it is a curved surface. The component of the force due to static liquid. So there will be two types of force which will be acting on this curved body. One is in the horizontal direction and one will be in the vertical direction, right? Two forces. The horizontal force will be nothing but it is equal to the projected area. If you find the projected area of this particular curved surface, it will be somewhat like this. So on this projected area, the force you can find, this is the horizontal force is equal to what? It is equal to hydrostatic force. It is hydrostatic force on projected surface. जो projected surface होगा curved surface का, उस पे जो horizontal force होगी, okay? And that is nothing but it is equal to rho g a x bar, okay? This is the value. What is this? It is area of the curved surface into pressure at the centroid of the submerged area. What is the pressure at the centroid? Can you tell me? Can you tell me what is the pressure in the centroid? See, weight of the liquid supported by the curved surface. This is nothing but this is the vertical component of the force. Vertical component of the force will be this. It is equal to weight, and the horizontal component will be equal to component of force due to static liquid. Due to static liquid, this will be the answer. Okay, it is equal to this value. It is area into rho g x bar. Rho g x bar is nothing but the pressure. It is equal to pressure. Pressure is equal to rho g h. You know that, right? So h here is the centroid, position of centroid. So option will be answer C. Next, the velocity distribution over a flat plate is given by. फ्लैट प्लेट के ऊपर वेलोसिटी डिस्ट्रीब्यूशन आपको गिवन है, इन विच u इज द वेलोसिटी इन मीटर पर सेकेंड एट अ डिस्टेंस y मीटर अबव द प्लेट. व्हाट इज द shear stress value at y is equal to 0.15 meter. Dynamic viscosity is also given 8 poise. What is poise? 1 poise is equal to 1 by 10 Pascal second. Okay, so you can get the value of you can get the dynamic viscosity in Pascal second, right? Clear? So how to find the value of shear stress? Shear stress is equal to mu du by dy. How you get this formula? This is nothing but Newton's law of viscosity. You apply the Newton's law of viscosity, apply करेंगे, then you will get the answer. Okay, you can get the shear stress. Now here it is there is one catch also, that you have to find this value at y is equal to 0.15 meter. At y is equal to 0.15 meter. Any buffering issue? Just a second. Any problem in the internet? Just a second. Any issue in the session, please let me know. And those who have joined the session, please do not forget to like and share the session also. I can see the viewership, that is the students who are coming live in the session are declined due to some reason. I don't know what's the possible reason for that. But all the students, please let me know if you are having any issue, just let me know. Okay. I think there is some issue in the internet. Any problem in the session? Any problem? Any buffering issue? Okay, no. Okay, thank you so much for response. So you just have to do the derivation here, du by dy. Du by dy will be equal to what? It is 1 minus 2y. Now you just have to put the value of 0.15. So du by dy at y is equal to 0.15 will be equal to 1 minus 2 into 0.15. From here you will get this value. Put this value here, mu is equal to 0.8 into this 1 minus 2 into 0.15. Solve it, you will get the answer. What is the answer you are getting? Tell me. Yes, everyone. What value you are getting? Okay, it's a very simple calculation. You will get 0.56 Newton per meter square. Next question. Pseudoplastic fluid is a fluid for which? What is a pseudoplastic fluid? Pseudoplastic fluid is a fluid for which you know that it is also called as shear thinning fluid. So viscosity is definitely going to decrease, right? It is a shear thinning fluid. Example is like blood, milk, some kinds of paint also. Some kind of paints are also pseudoplastic. So definitely the viscosity is going to decrease. At dynamic viscosity decreases, the rate of shear increases. So what will the answer for this question? Is viscosity going to increase? No. Is viscosity going to increase? No. Newton's law of viscosity will hold? No. It is Newton's law of viscosity hold for a Newtonian fluid. Okay, it is a non-Newtonian fluid. So option A will be the right answer. Okay. Pseudoplastic fluid is a non-Newtonian fluid. It is not a Newtonian fluid. Non-Newtonian fluid. What is a non-Newtonian fluid? The fluid which does not follow Newton's law of viscosity. Okay. Newton's law of viscosity hold only for a Newtonian fluid. Okay. Newtonian fluid is like air, water. These are example of Newtonian fluid. But these blood, milk, paint, they are pseudoplastic fluid. Okay. Shear thinning fluids. Next, free surface of a liquid behaves like a sheet and tends to contract to smallest possible area due to the. So my dear students, you know this when water, right now this is in many parts of the country you will find a lot of rain, and when you see the rain droplets fall on a flat surface, they tend to take the shape of a sphere. So it is not deliberately that they want to take the shape of a sphere. It is a minimum possible area that they can have, that is the sphere. Okay. Also, if you see that in some places where there is water, over the surface of the water you will find some mosquitoes breeding in the drain. देखा होगा मच्छर को आपने पानी में बैठे हुए. So how is it possible that a mosquito can sit over the water? Because of the surface tension effect. This is what surface tension. And the main reason behind the surface tension is cohesive forces. The cohesive forces of the water are responsible for the surface tension effect. Okay. So cohesive forces, the force of attraction between same types of molecules. The force of cohesion is responsible for the effect of that water droplet, soap bubble. They are able to take a particular kind of shape. एक तरह का shape लेते हैं. And also if you see this, that how the mosquito or any kind of insect is able to sit over the water, right? Because these kind of insect, it feels like it is a surface, but that surface formed because of a tensile force acting over the entire surface. Okay. A piece of metal having specific gravity 13.6 is placed in the mercury of specific gravity 13.6 under this situation. Now what you see in this particular case, let's say we have a container and that container is containing mercury. It is containing mercury, and in this mercury you have a metal. It is a metal We have a metal, we want to place it, and this metal, just a second. So when this metal will be placed here, both are having, this metal is having a specific gravity of 13.6, that is 3600, 13600, and this is mercury. It is also having a specific gravity of 13.6. Now you must have studied the stability condition. Hello Gurudat, Sergi old. Hi Alco Gaming. I can find some few old students also whom I used to teach during my days of when I used to teach for grade up. until grade up was acquired and the name was changed. English में course launch होगा. Alco Gaming, no, right now our course is only in the English language. About the Hindi language, or sorry, English course, it depends on how many queries we are getting from students. अगर हमारे पास ज़्यादा demand होगी, that students will demand more for the English course, will definitely launch. Okay. The metal piece will sink to the bottom. This will happen only when the density of the density of the metal is more than density of the mercury. Then this situation happens. Metal piece will immerse in the mercury by half. Half immerse? No, this is not correct. This is not correct. Metal piece will float over the surface of mercury with no immersion. The whole of the metal piece will be immersed with its top surface just at the mercury. Yes, this is the condition. So the right answer for this question will be option number D. When there is any condition that metal is density of any metal which is basically submerged in a liquid, it is equal to density of the mercury or any fluid, then this situation will take place. Okay. This situation takes place when density of the metal is less than density of the mercury. Then this floating situation takes place. Okay, then body will be partially submerged. बाजिश में था आपके साथ. Yes, yes. Okay, Alku. See, about the queries regarding, अगर आप लोग हिंदी में पढ़ना चाहते हैं, then English में पढ़ना चाहते हैं, these are all the queries we have already discussed. कि अगर आपकी ऐसी कोई queries हैं and we get more response, more demand from the students, then we'll definitely launch classes in English also. But as if now, our courses are only in English right now. Okay. Center of gravity of the volume of a liquid displaced by an immersed body is called. What is that called? Center of a gravity. What is the name of the center of gravity of the displaced fluid? Displaced fluid की center of gravity को क्या बोला जाता है? Center of gravity बोलते हैं. It is called metacenter, centroid or center of buoyancy. So the right answer for this question is center of buoyancy. Okay, clear? That is called as center of buoyancy. Those who have just joined me for this session, if you have not liked and shared the session, then please don't hesitate to like and share the session. Okay, please hit the like button and share the session. What is center of buoyancy for any submerged body? Just a second. Okay, just a second. Center of buoyancy is also called center of gravity. It is also called center of gravity of displaced fluid. Center of gravity of displaced fluid. जो displaced fluid होता है, displaced fluid का मतलब क्या है? अगर मैं इस कप को, if I put this cup in a water, right, in a container which is containing water or any fluid, then this cup will try to displace what? That fluid which is in which I am trying to place this cup, right? Agar if I have a bucket which is containing water, and in that bucket I am trying to put this cup, so this cup will occupy some space. So while occupying this space, it will displace some water, right? So that is the meaning of displaced fluid. It is also called center of gravity of displaced fluid, center of buoyancy. Next, the discharge through a venturi meter is given by the formula. Venturi meter based on the Bernoulli principle. It is the application of Bernoulli, right? Bernoulli's equation के based है आपका, Bernoulli principle based है आपका, and the discharge formula for the venturi meter is Q is equal to C. It is coefficient of venturi meter. Okay, it is also called coefficient of discharge of venturi meter. You can say discharge, whose value is actually between 0.95 to 0.98. Value of coefficient of discharge, and the value that you are seeing here, this is the value of actual discharge, and the formula will be option. It's a little bit mixed. Some mistake it is given. I think A1, A2. So actually, actual formula is actual discharge is equal to coefficient of discharge into A1 into A2 over under root A1 square minus A2 square under root 2GH. This is formula. None of the formula matches here, right? So the right answer is option D for this question. इनमें से कोई भी option match नहीं हो रहा है. So the right answer will be option D. None of the above. Next question, how could Magnus effect be stimulated as a combination? What is the meaning of Magnus effect? Any idea what is the meaning of Magnus effect? Have you heard about Magnus effect? किस टॉपिक में पढ़ते हैं आप लोग Magnus effect? So let's say we have an object which is spinning or it is rotating at its axis. Okay, so this particular object is rotating or spinning, and it is spinning through a moving fluid, and it is spinning through a moving fluid. The fluid is moving across this object like this. Okay, this is a kind of a fluid. This is the fluid, and in that fluid is an object is spinning or rotating like this. This is an object. Object is spinning in a moving fluid. That is called as Magnus effect. That phenomenon is called as Magnus effect. So whenever this thing happen, what will happen? When a spinning object, spinning means it is rotating at its axis. Moving through a fluid, then a lift force acts on the object. तो ऑब्जेक्ट के ऊपर क्या होता है? एक लिफ्ट फोर्स एक्ट करता है, राइट? लिफ्ट फोर्स जानते हैं ना, इसको मूव करता है ऊपर की तरफ, imparts a force in the vertical direction. Okay, that is called as Magnus effect. इसी को Magnus effect कहते हैं. But how you characterize the Magnus effect? Can you tell me? Yes, everyone. How can you tell which of the following situation जो यहाँ पे mention करी गई हैं, which tell you about the Magnus effect? Just wait for a minute. Okay, so the condition I have explained, but in which condition you will get this Magnus effect? The answer will be option B. When the flow is uniform and it is irrotational flow, you will find some vortices and a doublet is formed. Okay, that is a condition of a Magnus effect. Okay, so when these all conditions are applied, that is, the flow is uniform, irrotational, vortex, and a doublet is formed. So this is, and what is an example of Magnus effect? Example of Magnus effect is is propulsion of the ships. जो ship का जो movement होता है, that is example of Magnus effect. That is a example you will find, and it is also the example is in the in the game of table tennis. You will find that on the ball you will find this same effect. Okay, in the golf also you will find this effect of Magnus effect, right? Magnus effect. So this is the answer. Option B will be the right answer. A potential function exists for. What is the condition for potential function to exist? Potential function exists for three-dimensional flow, and irrotational flow. It only exists for irrotational flow and three-dimensional flow, and 2D also, 2D and 3D flow, 2D and 3D and irrotational flow. So what is the right answer for this question? Two-dimensional irrotational flow only. This is not correct because it is not applicable only for two-dimensional. It is applicable for 2D and 3D both. Steady flow only, not correct. Irrotational flow, whether compressible or incompressible. Irrotational flow of incompressible fluids only. What will be the answer for this question? Potential flow exists for. So I have told you the conditions. Okay. Potential flow exists for. One second. It is definitely correct that it exists for irrotational flow. That is for sure. क्या होगा इसका आंसर? It exists for irrotational flow of only incompressible fluid. Very good. Option D is the right answer. Only incompressible fluids. Clear? In the region of the boundary layer on a flat plate, where velocity is not zero, the viscous force is. Yes, tell me. In the boundary layer, wherever boundary layer is formed, let's say we have a flat plate, and in this over this flat plate, you will find the boundary layer. So inside the boundary layer, you will find these kind of velocity gradients are formed. Okay. So when the velocity gradients are formed inside this boundary layer, inside the boundary layer, where velocity is not zero. Where the velocity is not zero? Velocity is zero on this condition. Here it is, velocity is equal to zero. This is called as no slip condition, only on the flat plate. Here only velocity is zero, and on the other places velocity is, but in the region of boundary layer, that is inside boundary layer. What is the meaning of region? Inside boundary layer. Basically they are saying inside boundary layer. So inside boundary layer, basically they are saying where velocity is not zero, then viscous force, the viscous force will be less than the inertial force or more than inertial force. It will be more than the inertial force. They will be dominated over the inertial force. Okay. So right answer will be option B for this question. Clear? Is it clear? Any doubt? If you are having any doubt so far in any question, you can just ask me. Okay. किसी भी तरह का doubt है, if you are having any doubt, whether you want me to explain in Hindi. See, I know that we are providing these classes in English, but if any student is having some doubt, I can try to explain in Hindi also. Okay, no problem. That's not a case. I can basically translate in Hindi. That's not a problem. But I will be teaching only in English. But if any student want me to translate, I can do that. For a linear distribution of velocity, what is the meaning of linear distribution of velocity? Linear distribution of the velocity means the velocity profile is this, like this. U by V infinity is equal to Y by delta. This is called as linear velocity profile. इसको हम क्या बोलते हैं? It is also called linear velocity profile. Okay. In a linear velocity profile, on the flat plate, the ratio of displacement thickness to nominal thickness. What is nominal thickness? It is also called as boundary layer thickness. boundary layer thickness. Okay. So I have told you that whenever you find this linear velocity profile in the case of boundary layer, then the displacement thickness whenever you find this kind of this velocity profile, then displacement thickness will be equal to delta by 2. Okay, clear? So when if it is delta by 2 and divided by nominal thickness, so this will be divided by nominal thickness, this will be 1 by 2. The answer will be 1 by 2. Clear? Next, which of the following represents steady non-uniform flow? Steady flow and but non-uniform. So I have already explained that steady is that when anything is happening at constant rate. So if you find somewhere written constant rate, then that will be steady. If it is increasing rate, that is unsteady. Increasing or decreasing rate, that is unsteady, that is changing with time. Okay, so option A and C will not be the answer because they are unsteady. What about the steady, where it is constant? Here it is constant, here it is constant, but non-uniform. When it is a long pipe, it is case of uniform flow. So it is uniform and steady. And when it is an expanding tube, the tube is increasing, then it is non-uniform. Okay, so non-uniform and steady, option B. Clear? Is it clear to all of you? Tell me, everyone. All right. The velocity of the water stream is being measured by L-shaped pitot tube. Pitot tube is definitely, as you know, the application of Bernoulli. It is used to measure the velocity of the pipe flow. Velocity of the fluid in the pipe and open channel. Okay. It is a L-shaped tube or tube bent at 90 degree, and it is used to find the velocity, that is equal to under root 2gh. Okay. Now, L-shaped pitot tube having the reading of 20 centimeter, what is the velocity? So reading is given 20 centimeter, just put the value here, 2 into g, that is 9.81, and this is 20 centimeter, which is equal to 0.2 meter. You have to put in meter, right? Solve it, you will get the answer. Okay, 196 nahi hoga, this is 1.96, sorry, 1.96, it's written incorrectly. Point, this should be point. Okay, solve it, everyone. Tell me the answer. If you have to find the square root, you can take the calculator also. Take the help of calculator. Not a problem. Again, I'm telling you that you don't have to do mistake. Okay, just get the right answer. 98 nahi hoga, 9.8 hoga. So this will be somewhat around 1.96. Option A, 1.96 or 1.98. Next question. Of the various method of measuring discharge through a pipeline, the one with the least loss of energy and direct reading is by. Least loss of energy means less loss of energy. We are measuring the discharge. So discharge can be measured by all these devices. Okay, pitot static probe is basically used to find the velocity. And direct reading you are getting. So we can definitely use the least loss of energy. Energy loss is very less. Venturi meter and orifice meter and flow nozzle. Out of these, which will be having, this is also the last question for today's session, and I want to share this thing with you that I think there's some issue in my Microsoft Office where I cannot save the PDF. The reason I was not able to share the PDF with you, I was thinking of sharing the PDF, but as soon as I saw that where are my PDFs which I have saved, the PDFs are not available because it may be only because that I think there's some problem with my Microsoft Office. PDF cannot be saved here. So the answer will be option A, Venturi meter. Okay. So Venturi meter is the right answer. It is having more coefficient of discharge is more. This is around 0.95 to 0.98. Okay. This is having coefficient discharge is equal to 0.68 to 0.74. it is having more loss of energy, although it is cheaper than venturimeter as a device to measure discharge, but it is having more loss of energy. This is having less loss of energy, so it is having more coefficient of discharge. You get more discharge from venturimeter. So that's all, and I think 1 or 2 questions were left, but those who have joined me for this session, I hope you guys have subscribed the YouTube channel. If you're not, please do that. And also, if you have not liked the session, please do hit the like button and share the session also. Thank you so much for coming to this session. I'll see you tomorrow, and tomorrow will be the session on the top thermodynamics and application. Thermodynamics I have already taken, but tomorrow will be thermodynamics application. When we say thermodynamic application, we are basically talking about 3 subjects: IC engine, RAC, and PP. What is PP? It is power plant. So these 3 subjects. No, this is the theme of our PPTs. Actually, PPT को इसी तरीके से डिज़ाइन किया गया है. That background is like this. So I cannot do anything in that. If you are having any reading issue, then you can just let me know, Prisma. I can try to make my writing more clear. Okay. All right. Thank you so much, everyone. I'll see you on tomorrow at 8 PM. कल फिर मुलाकात होगी 8 PM पे. And thank you so much. Have a nice day. Thank you so much.